Hello, this is Mr. Munson, and we're in Chapter 4. We're getting ready to start a whole brand new chapter. This is one of my favorite chapters because it's dealing with triangles, and triangles is a really important topic when we're dealing with geometry. So let's get started. This is going to be, this lesson is going to cover concepts 1, 2, and 3. And basically, we're looking at classifying triangles, relationships between angles in a triangle, and the relationship between exterior angles and the relationship an exterior angle has with a triangle. Okay, let's move on. Okay, as you predicted, we have a vocabulary list that we're going to have to go through here for this section. If you put me on pause right now and go down to the description, which is a box just below the video when you open it up on YouTube, and there's a link there. I want you to click on that link, print up the vocabulary sheet, and then come back and continue the video. Okay, so put me on pause, go get that sheet. I expect to see that sheet next class filled out. Okay, here we are. We're back. And so let's take a look at these vocabulary words. Let's start with the first one, scalene. Okay, so a triangle is scalene if none of the sides are congruent. Okay, triangle with no congruent sides. So here's an example of a scalene triangle, 3, 4, 5. Now, if you look at the list below you here, these first few vocabulary words are all classification of triangles. And so we can classify a triangle by if we know something about its sides or something about an angle. So for instance, we'll get down there, but you can see acute is one of the words here. So an acute triangle is a triangle where all the angles are acute, smaller than 90 degrees. So in this case, a scalene triangle is called scalene because we know something about its sides. An acute triangle is called acute because we know something about its angles. All right, let's continue. So an isosceles triangle is a triangle with two congruent sides. So in the drawing, you'll see I have a triangle there. It has a 3, and a 5. So we know something about sides, so we can call it by a name that references its sides. Isosceles is a classification for a triangle when we know something about the sides. So an equilateral triangle is a triangle with 3 congruent sides. All right, very easy. Equilateral, lateral means sides. So when you start off with equa, it means equal sides. And so there you have it, an equilateral triangle. All 3 sides are congruent. If you know that, then equiangular would mean all 3 angles are equal. And when we get there, that'll be an easy one for you to know. So here we have an acute triangle. And so a triangle with 3 acute angles. All angles are less than 90 degrees. So my example here is a 36, 82, and 62. And if my math is right, then when I add all 3 of those up, they should equal, and in your mind, hopefully you just said the number 180 degrees. Okay, a triangle with 1 obtuse angle is called an obtuse triangle. And that obtuse angle has to be greater than 90. So in this case, I have a 36 degree, a 24 degree, and a 120 degree triangle. That 120 degree is what tips it into being obtuse. This is very important. There is absolutely no possible way to draw a triangle that has 2 obtuse angles. If you think about it, that would mean you have 2 angles that are greater than 90. Let's say that one is 91 and the other one's 92, just barely over the line. When I just add those 2 angles together, I get 183 degrees. Well, that doesn't leave anything left over for that third angle I haven't even talked about. So there's no possible way to have that. Okay, right triangle, a triangle with a right angle in it. So I have a right triangle drawn here. I have some important names for the sides of the triangle. If I look at the right angle, across from it is a side we will call the hypotenuse. And then the 2 sides that wrap or are on the 90 are called legs. Okay, so we have equiangular or equiangular triangle, and that means all the angles are equal to each other. So I have a drawing there, and hopefully you can recognize the congruent marks that show that the 3 angles are congruent. So the question is, the measure of each angle is how much? So if we know the sum of all those angles equals 180, at the very least we remember that from our n minus 2 times 180, and we just stick 3 in for the n. We see 3 minus 2 is 1. 1 times 180 is 80 degrees, 180 degrees. So each one of those angles is a regular polygon because all the angles are the same. That would mean that each one of those degrees is exactly the same. 180 divided by 3 gives me an angle measure of 60 degrees. So the triangle sum theorem, and we're going to put this here, but later on we're going to put it on your formula sheet. The triangle sum theorem says this: the sum of the interior angles of a triangle is equal to 180. We already know this from our n minus 2 equation, okay? But this is a theorem, and it's just a quick way of stating it. And we'll just forever and ever now know that the sum of the interior angles have to add up to 180 degrees. Well, using that theorem and the triangle here to the right, I could write the equation. And so 60 plus 40 plus x equals 180. So the sum of the angles equal 180. I could simply use my math skills to solve. All right, I want to jump down to remote interior angles before doing exterior angle. I kind of have that out of a logical order, so I want to fix that here. All right, let's continue. Actually, again, I apologize. I'm looking at the exterior angle here. I thought it said exterior angle theorem, so we'll just continue. Exterior angle. Look at an exterior angle. That's the angle formed by extending a side of a triangle. So take a look at my triangle here. If I extend this side, it forms this angle. And if I was to extend this side, it would form this angle. And if I extended this side, it would form this angle. It's important to note that the inside angle of the triangle and the exterior angle that lies next to it are a linear pair. Okay, remote interior angles. There's two that are always associated with any exterior angle. So the definition is the two interior angles that are not adjacent to an exterior angle. So let's take a look what that means in picture form. So to get an exterior angle, I'm going to extend this side. So here's the exterior angle. If you take a look at the angle that's next to it, right here, that's the interior angle that is adjacent to that exterior angle. So the two remotes are the ones on the opposite sides. We'll call it remote 1 and remote 2. Every exterior angle has two remote angles that are associated to it. So draw yourself another triangle like this, and then I'm going to extend one of the sides this way to create an exterior angle. Put the R1 and R2 in the proper places to represent remote 1 and remote 2. Hopefully you put remote 1 here and remote 2 or vice versa, just as long as it's not next to the adjacent. Or should I say the exterior angle, not adjacent to the exterior angle. So that's kind of going to be written like this. Okay, so the exterior angle is equal to the sum of the two remotes. So there's an example of a problem that we'll look at some more examples in our lesson, of course, but here's an example that you can put on your formula sheet for quick or your vocabulary sheet for quick reference. So the exterior angle, which is 2x, is equal to the sum of the two remotes, 31 and 82. So that's pretty much it for our vocabulary. And we're going to actually have a couple that are going to add to our formula sheet. You already have them on the vocabulary sheet, but your formula sheet's going to have them. Let's go ahead and look at some problems and see if you know how to do them. So one of the I can statements that you need to do is be able to look at a triangle like this and classify it by its side lengths. So I'm giving you the side lengths, and so you have to look at your definitions and know them by heart to recognize which one this is. I recognize that all those sides are different, so that makes it a scalene triangle. In this particular instance, right now, with the knowledge that I have, I don't know anything about the angles, so I can't look at the classification names that we have for triangles when we know something about the angles. So we can't call it a right triangle, we can't call it an obtuse triangle, we can't call it an equiangular triangle, we can't call it a obtuse triangle or an acute. I might have named one of those twice. Okay, let's see if you understand this idea. So now what we're going to do is we're going to look at classifying triangles by its angle measures. So a lot of times I'll give you the three angles, and you go and look at it and ask yourself, if there's an obtuse angle in there, then you're going to call it an obtuse triangle. If there's a right angle in there, then you call it a right angle. If all the angles are acute, then it's an acute triangle. And so this is a kind of a classic problem where you're given two of the angles. And so a lot of times students will jump on it and call it an acute triangle because both these angles are less than 90. But the problem is we don't know what this angle is. And before we call a triangle its name, we need to know all three angles. So what we're going to do is use the triangle sum theorem to find that missing angle and then simply make sure that we understand what kind of name it would be. Okay, it's helpful to write that equation. There's no numbers from the triangle in it. It's the standard equation for the triangle sum. And the reason it's important to do that is sometimes students can do this on their calculator, but as soon as I start adding x's and things like that, it all falls apart. So what we want to do is make sure that we have this basic equation down. So every time you're using the triangle sum theorem, I'm going to suggest that you write this big long thing down so that when we have expressions like x plus 2 and things like that for the angles, you know where to put them. Okay, so the measure of that angle is 120 degrees. And certainly it doesn't look like it's 120 degrees, and I'll never classify a triangle by the way it looks. I'll always have factual information. So in this case, we're looking at the angles. One of the angles is obtuse, so the answer is an obtuse triangle. All right. So sometimes students will get really used to looking at the triangles and determine what they look like versus the factual information, looking at the sides or the angles. So the triangle that we just did probably looks more like this thing in real life. This is a 120 degree angle down here at the bottom. And so, yeah, like I said, it probably looks more like that. So you don't want to trust your eyes, you want to trust your facts. All right, let's take a look at this exterior angle problem. See if you can set up an equation for it. I'm going to do that in just a second. Go ahead and put me on pause and see if you can do it, and then come back and check yourself. Okay, so I wrote the standard equation. And the more I do that, the more you do it, the better you're going to get at memorizing that equation and knowing where to put the pieces as they fall. Okay, so I can tell that the 2x is my exterior angle, so I placed it in the exterior angle spot. The 46 and the 82 are my remotes. It doesn't matter which one's 1 and which one's 2, so I stick them in the spot, and I'm just going to simply solve that equation. Okay, so x is equal to 64. Now there was no question to this problem about what to find, so I'm just going to assume that we wanted to find x. If they were asking me to find the exterior angle, I'd need to remember to plug it back in. All right, now try this one on your own. Put me on pause. And I got x equals 32. How about you? All right. All right, here's the try it problems. For tonight's assignment, I need to make sure that you draw the pictures, that you show your equations, and all work is there. On the last one where it says classify the triangle, when you write down the name of it, I want you to write down the reason why you wrote that name down. You know, again, it's very clear. So if you're going to have two answers for number 3, something about the sides and something about the angles, and then state a statement after it why you chose those names. All right, have a good one. That's it.